Okay, hi there students. I'm going to go over the solutions to the take-home component of the investigation that you were recently given in class. So if you're looking for help with this, you have come to the right place. Okay, just a little bit of background as to what this actually is. It's part of an assignment called an investigation, and the take-home section is the work you do at home to basically investigate a particular mathematical concept that we've decided to assess you on based on the Year 8 curriculum. Now for these 3 marks for the take-home section, you get 1 mark for handing it in on Monday, which is the day of the validation, 1 mark for having it completed, and then another mark for marking it and then making any corrections that you need to as well. So if you do all 3 of those things, you get 3 marks, and that's it. So the idea is you complete that, but then the validation assesses you on the content of this investigation. So this is worth 3 marks, but the actual validation is worth something like 41 or something like that. So you not only need to actually do the work, but you need to understand it as well. So we're going to go through this 1 question at a time, and you can pause the video if you like or whatever. You know how YouTube videos work, so if you want to go back at any time, please feel free. If you want to skip ahead, I've left some time codes in the description as well that you can jump to. Okay, so for question 1, we're converting the following fractions to decimals, and we're going to use the appropriate notation for recurring or repeating decimals. Okay, so if you want to convert a fraction to a decimal, all you've got to do is get your calculator handy, and you can take the numerator and divide it by the denominator. So 1 divided by 2, you can do that in your head obviously, but that's 0.5. Now you're asked to identify whether it's a terminating or a recurring decimal, which is something that we've been doing in class. Because we do 1 divided by 2, we get 0.5, and that's it. It doesn't keep going. We can safely say that that's a terminating decimal. So I'm just going to mark that as T. 1 divided by 3 is a little bit different, so 1 over 3 is a fraction. If you type this into your calculator, you'll get 0.33333, and so on, and that 0.333 is going to go on forever. Now the way that we represent that is to say 0.3, and we do a little dot above the 3 to show that that 3 is recurring. So that little symbol, that dot above the 3, is going to say, well, it's at 0.3, but that digit 3 is going to keep going forever. And that makes it a recurring decimal. 1 over 4 is easy enough. That's 0.25, so a quarter. Because it finishes there, that's a terminating decimal. 1 over 5 is similar. That's 0.2, which is terminating as well. 1 over 6 is a little different. If you type this into your calculator, you'll get 0.16, and then that 6 will keep repeating forever. So 6, 6, 6, 6, 6. So we do something similar with this answer. We want to put that dot above the 6 to show that that number 6 is recurring. So it's not 1 6 that repeats, it's just the number 6 that's on there. So that's going to make that a recurring decimal. 1 over 7 is a little different again. So if you type this into your calculator, so do 1 divided by 7, you'll find that your answer is 0.142857, I'm pretty sure, yep. And if your calculator was large enough, you notice that the next few digits on there are 1, 4, 2, 8, and you get that repeating pattern of 1, 4, 2, 8, 5, 7 going on forever. So in this case, it's not 1 digit that repeats, it's a whole set of numbers. So to show that that it's that section of numbers that repeat, so we're getting 1, 4, 2, 8, 5, 7 again and again and again, the way that we note that down is to draw a big line over the top like this. Sometimes you'll see that written instead as having a dot above the first digit and the last digit that repeats, which shows it's the 1, 4, 2, 8, 5, 7 group that repeats. So if you've got 2 dots, it shows that range. I quite like drawing the bar over the top because it's clearer, but you know, both of those, or I feel it's clearer at least, but both of those are correct should you wish to use them. So that's going to be a repeating decimal, that one. Okay, I'm going to skip through to the end of these. Okay, so that was pretty similar. So 1 over 9, for example, gave us 0.1 recurring, so the 1 recurs for that one. Whereas say 1 over 11, it's the digits 0 and 9 that repeat, which is where we put that repeating decimal. Say it's 0.9 that repeats, so 1.090, sorry, not 0.9, it's 0.9 that repeats over and over again. So that's another repeating decimal. Okay. This next one, we need to find the prime factors of the denominator for each of the following fractions. Okay, so there's a couple of words to point out there. Prime factors, well, factors are numbers that can fit into another number. So the factors of 12, for example, are all the numbers that fit into 12. So 1, 2, 3, 4, 6, and 12. What we're looking for this one is the prime factors of each of those numbers. So we're interested in the factors, but it's only the prime numbers that will fit in there. Now just as a quick reminder, prime numbers are numbers that can be divided by only themselves and 1. So the first few are 2, 3, not 4 because 2 goes into 4 as well, 5, 7, 11, 13. So they're the first handful of prime numbers, and they're the main ones that we're going to use for this, this next part. Okay, so what we want to do here is find the prime factors of each of the denominators for these fractions. So 1 over 2, for example, the only prime number that can fit into that is 2. So our prime factor here is 2. Only number that will fit into 3 that's a prime number is 3. The only prime number that will fit into 4 is 2, not 4 because we're only looking for prime numbers. Prime number that fits into 5 is 5, and then say for 6, the prime numbers that fit into that would be 2 and 3. I'm going to quickly race through this table, and I'm also going to indicate whether these are terminating or recurring. For your work, you can just copy this from the first page if you wish to. Okay, so now I'm done filling in that table. So the next part of this is we've got to see if we can find a relationship between the prime factors of the denominator of a fraction, and then make a link between that and whether the decimal it produces is a terminating or a recurring decimal. So what we're going to do for this one is focus on the prime factors of terminating decimals. Okay. So I'm going to look through this once again. So we've got a terminating decimal here. My prime factor was 2 for this one. Terminating decimal of 1 over 4. It was terminating and my prime factor was 2. 1 over 5 terminates, that was just 5. 1 over 8 terminates, that was 2. And 1 over 10 terminates, that's 2 and 5. Okay, the key takeaway here, so the thing that we hope through your investigating, the thing that you actually find out, is that when we have a denominator with prime factors of either 2 or 5 or just 2 and 5, so nothing else, then the decimal it produces is going to be a terminating decimal. If you had a 3 or an 11 or a 7 or any other prime number, it's going to produce a recurring or a repeating decimal. That's also the case if you've got a denominator that's got, say, prime factors of 2 and 3, like 15, for example. It has to be just 2, just 5, or 2 and 5 only. Okay, so you can summarize it with an expression like that. They have prime factors of 2 and or 5 only. My and or is a little dodgy with my tablet that I'm writing on, but I hope you'll forgive me. Okay, so now we're going to do the same thing again, but this is the part that you could then go on and do. You can check this against the solutions rather than me working through the whole thing for this one. But say the fraction 1 over 12, I'll remind myself of that as a decimal. So as a decimal, 1 over 12 will give me 0.083 recurring. So that's a recurring decimal. So we're going to expect to see prime factors of the denominator that are other than 2 and 5. And 3 is something that strikes me as something that fits into 12 straight away. So prime factors of 12 are just going to be 2 and 3. And for these larger numbers, the way that you can check to see if they, what prime numbers make them up, is to use something called a factor tree. I'll just sort of draw this over the top here. So if I take the number 12, for example, I'm going to divide that by a prime number that I can think of that fits into it. 2 works, and 2 is going to fit into 12 6 times. So I've got 2 and 6. I've split it up using those factors. 2 multiplied by 6 gives me 12. 6 isn't a prime number, so I'll divide that by a prime number I can think of that fits into it. 2 will go into it, and 3 will go into it as well. We can't go any further because now we've got all prime numbers. So that's how we can identify that 2 and 3 are the prime factors. Number. If it's an even number, you can start by dividing by 2. If it ends in 5 or 0, you can divide by 5 and so on. I'll do one more for you as an example, and the rest you can check against these solutions. 1 over, let's do 1 over 24, I think. So this as a decimal gives us 0.0416 recurring. And this is the way that we write that down. And if I wanted to find the prime factors of 24, I can see that 2 fits into it, but there's another number as well that I'll show you using prime factors actually. That might help you. Okay, so divide 24 by 2. That will give us 12. I'll divide 12 by another prime number that I know as well, which could be 2, which is going to give me 6. And this looks pretty familiar with the last one. 6 divided by 2 is going to give us 3. So now I've identified that 3 and 2 are my prime factors of 24. And like we've said before, because it's not 2 and or 5 only, that's the reason that we're getting a recurring decimal for this question. So we've got 2 and 3 for this one. The next number, 1 over 25, that would give us 0.04 as a terminating decimal. And if you split up 25 in this way using a factor tree, the only way you can do it is to do 5 multiplied by 5, which is 25. So 5 is our only prime factor of 25. Okay, so now scrolling a bit further down so you can check the rest of these against these solutions. Does your answer for 2b hold true for this table? You pretty much just say yes. Terminating decimals only have prime factors of 2, 5, or the 2 of them combined, but no more.